Hey there. In this video I want to show you some basic programming with Visual Basic for Applications, or VBA. VBA is the programming language behind Access and other Office applications, and once you learn how to use it, you can do pretty much anything that you want with Access. And in this example I'm just going to show you how to get a sum of figures from a table. We have an invoices table here in the example application, and I want to get the invoice amount over 60 days. So we have a number of invoices. As you can see, they have the invoice date, they have the customer and an invoice amount, and I just want to know how much of this is more than 60 days in the past. So again, we have the invoices table here, and we also have a query which I'm going to use as part of the program, amount over X days. Let's take a look at that. Open up in Design View. Go ahead and maximize the window. It's looking at the invoices table. We have an invoice amount, which is this field. It's being treated as a sum, so the query is automatically going to create a sum of whatever it finds. And then we have the invoice date column being used solely as criteria. It's saying just pull the invoices where the date is more than 120 days in the past. It's using the date add function there. And let's go ahead and change that to 60 for now. Not 760, 60. There we go. And let's go ahead and run that. Just see what it gives us. So we're seeing that there's over $300,000 that's more than 60 days in the past, which is probably not great for the company. And that's that query. We're going to be using that in the program. Now, there are a number of ways to actually do this, depending on where you're displaying the information. If you're displaying it on a report, you could do this with a simple one-line function, but I want to show you how to do this in programming. So let's go ahead and create a module, and for that we go to Create and Module, and the program automatically opens the Visual Basic for Applications, or VBA environment, creates a new module. That's the object within an Access database that actually holds code that you can refer back to. It's automatically named it Module 1, so let's go ahead and save this right now and call that General. And just to go over the VBA environment real quick, we have the coding area where we're going to write all the code. We have the database objects list, which shows all the objects within the database, such as forms and reports that hold code. And we have the immediate area where we can perform basic calculations or look at variables or parts of the code to do some testing. And there are a number of other windows available, but right now what I want to do is go ahead and create a basic function. And we do that by coming over here to the coding area and typing public function, and let's call this get amount over X days, because I'm going to make this kind of flexible. Put parentheses after that. You can always design functions to accept arguments that the function will use in its calculations. This one doesn't need any yet. As soon as I hit enter, it goes ahead and ends the end function statement. So now we have a function declaration, and the main purpose of a function in programming is to return a value. We want this code to get a value from the table and return it to us. You can also do subroutines like public sub get info. Subroutines are meant to carry out operations and do pretty much everything else. Functions are just meant to return values. So we're going to start off with a very simple function, and there's actually a very simple way that you can do this in VBA. And that way is to use the DSum function. And that stands for domain sum. And what it does is actually to obtain a sum of values from within a domain, which in this case is the table. So let's start with DSum, put a parentheses, and we're going to look back at the query where we have the table and its columns, and we're going to type invoices, and actually let me put in brackets, say invoices, invoice amount, then we put a comma, and as you can see, the tooltip actually guides you through writing the function. First it wanted the expression, which was a field that we're actually going to look at, and then it wants the domain, which would be the table itself, invoices. Now it wants criteria. It wants to know which records to look at. So for guidance in that, let's take a look at the actual SQL code. Now the SQL query actually says invoice date less than date add, and it uses the D to signify days, -60, and the current date. So wherever the invoice date is less than 60 days ago. So let's go back to the function, and we add in a second or a third section. See if it accepts it. It's wanting another parentheses somewhere. This can be one of the irritating things about working with VBA, when you're trying to get the number of parentheses right. Okay, it doesn't. Here we go, and that's what the problem is. I'm using the double quotes, and it's seeing that as the end of the string. Let's see if we can use single quotes instead. Okay, it's giving me another error because it sees these parentheses on the front and back. Usually you would say dim or dsum, and it accepts it. But we want to return this as a result. With a function, you need to return the value. So we're going to say get amount over x days equals, and now we need the parentheses, or else it gives us another error. So now when you're actually assigning it as a value, you do need those parentheses in there when you're using the dsum or dcount or dlookup functions. So now we have a one-line function. It's declared, and it's returning the result of an equation or a formula by assigning it to the function name, which is how you return function values within VBA. And it's actually saying -60. So let's see what this actually does when we run it. And to run it, in this case, we're going to come down to the immediate window and say print, and the question mark is the symbol for print here, get amount over x days. And it works. So we've written the first basic function. Now, this is hard-coded, as they say, to return the amount for over 60 days. And I could change that and run it again and pull up over 90 days or over 30 days. But that's not real convenient because you don't want your users going into your code and changing values when they need to. So I want to have this function return the amount for a specified number of days. So what I'm going to do is add a parameter to the function. I'm going to say number of days as integer. So I'm telling the function to accept an integer argument, essentially a whole number, called number of days. Whenever I call this function, I have to provide that number. And now we're going to take that argument and let's just insert it here. We're replacing the actual hard-coded number of days with the argument that is being supplied to the function. And let's see how that works. So we'll call it again, get number amount over x days. And now when I call it and I do that open parentheses, it's actually requesting that argument to fill the parameter that's specified as part of the function. So I'm going to say 30 days. The expression you entered as a query parameter produced this error, number of days. Okay, so let's see why it did that. As you might have already guessed, the reason it's doing that is because it's not treating number of days as a literal. This expression is already included in quotes. So it's simply adding the text number of days to the expression, and that expression won't take that text. What we actually have to do is construct the string to include the literal value that's being passed in. And we're going to do some concatenation. We're going to build a string. So we start by ending that string. We use the ampersand to say and number of days, use another ampersand, and then reopen the string. So what that's actually doing is creating a string from those components. So let's go ahead and put a breakpoint here and try running this again. Okay, so the code has paused execution on that breakpoint, and I'm going to copy this. I'm going to copy that concatenated string and see what it actually looks like. So that's what that string actually looks like to the code. Invoices, invoice date, less than, date, add, and 30 days. Now, there's still a problem because that says 30 days. I don't want it 30 days in the future, which is what that would do. I want it 30 days in the past. So I'm going to say times -1. And if I do times -1 here, I get -30. So that works as it should. So that's concatenation within VBA. And that's very often what you might have to do if you're passing in arguments and you want to insert them within your code. You might have to use the concatenation character, the ampersand. So now we have a function that will return the amount that's overdue by the specified number of days. We can say 30, we can say 60, We can even do an odd number like 67, and it will give us the proper result. Now that's fine. That one-line function is fine until you get into queries that include joins and some of the more complex aggregate functions like averages and sums over tables, and then it's not really set up to handle that. So we're going to try a more complex way, but one that allows for greater capability. I'm going to go ahead and stop execution on this, and let's go ahead and comment that out so that the compiler will ignore it. And the first thing I'm going to do is to start creating some variables. I'm going to say dim rst invoices as DAO record set. What I'm going to do in this next example is to actually open up the table, look for some records, and have VBA pull back the value that it finds. Instead of using one of VBA's functions, one of its pre-built functions, I'm going to have it do it manually. So what I've done is declared a record set, and DAO stands for Data Access Objects, which is a set of methods that VBA uses to actually communicate with the tables within an Access database. And it's going to pull the records that I specify and put them into that record set objects so that I can go ahead and use it. So I've declared it, and now I'm going to actually do what's called instantiating it. When you instantiate an object, you actually create an instance of that object. So I'm going to say set rst invoice equals current, that's not an equal sign, current db open record set. So I'm using the current database object. This is an object within VBA that represents the current database, and I'm using a method within that object called open record set, which will actually open a set of records such as a table or a query. And what I'm going to do is go back to the query that I created earlier, and I'm going to copy that SQL, and then I'm going to paste it in. First, I want to create a string variable, dim string SQL as string. And a string is a data type. It just holds alphanumeric data. It just holds text. So I'm going to put that query into the string SQL equals, and I'm going to use a line continuation character so that I can keep this neat. Okay, so let's comment this out for a second. I want to show you exactly what that does. And I'm going to place a breakpoint here and get amount over X days 30. So it stops right there. And I'm going to press F8 to step through one line at a time. And it's constructed the string. Let's see if we can get it to actually print it out. That's how the string exists at this point. So that's the SQL that it's going to work with. But there's the problem, because it's not seeing number of days. So let's stop execution, and let's do the same thing we did here. And let's try it again. Okay, so that should work. that SQL should work when the program runs it. So let's close that. Let's remove that breakpoint, remove that commenting string SQL. So we have a SQL statement that's held within this string variable, and we have the open record set method that's opening a set of records based on that SQL statement and passing it back to the record set object that we declared up here. So now we're going to have an object in memory that's going to hold whatever data has been obtained by that SQL statement, and we can work with that, we can reference it. Now the next thing we want to do is check for the end of file. This query, we know this is going to return data because it's actually counting the number of records. If there is no records, it's going to return a 0. But just for the sake of getting into the proper habits, we're going to say if not RST invoice EOF, then we're using a simple if-then statement. We're checking for the end of file. So in other words, we're making sure that the query actually returns some records. If it doesn't, then you'll be at the end of file on the record set. But if it's not at the end of file, we know there's some records there. And what I'm going to do now is declare one more variable, dim int or dim dbl, and amount as double, or actually I'm going to make it currency. So I'm declaring a currency value that's actually going to hold the value that's being returned by the record set. And I'm going to say RST invoice, or no, sorry, DBL amount equals RST invoice and sum of invoice amount. Now, where I'm getting this is, again, we named the record set RST invoice, so we're referring to the current record within the record set. We're referring to the record set and the specific column. As you can see, the SQL names the column sum of invoice amount. If we went back to the actual query, we could view it. It's calling it sum of invoice amount. So that's the name that we refer to it as. And when it comes down to this point, it should put that value right into the variable. And then, once it's done that, I want to come down here and actually return the value to whatever code or whatever process is calling this function. When you're writing a function, you actually do have to return a value at some point. So to do that, we say get amount over X days equals DBL amount. You're simply setting the function itself to be equal to the return value. Okay, so I'm ready to test this. I'm just going to go ahead and get rid of this line entirely, not using that anymore. And this function is not really done. I don't have error handling. I don't have some of the other best practices involved here, but it's a very basic function, and I want to see if it works. So I'm going to go ahead and let's just go ahead and use this. Get amount over X days, 30, and it works first time. That doesn't always happen. Very often doesn't happen. Doesn't work the first time, but it works. Go to 60. Go to 99. Now, as I said, there's a number of other things that we would do to actually complete a function like this. I would put in some error handling like this. And I would put in some commenting here and there to make it clear what it's doing. I would actually close the record set after I'm done with it. With objects within VBA, you want to explicitly get rid of them. In this case, that means RST invoice close, actually closing the record set, and then set RST invoice equals nothing. And what that does, it closes the connection to the database and destroys the object so that it's not taking up room in memory anymore. Now, this would often be done when the function ends anyway, but for the sake of caution and code neatness, you want to go ahead and get rid of objects that you're using. You don't have to do it with strings and currencies because those are single values, those are stored differently, but with objects where you use the set keyword in order to set them, yeah, you actually go ahead and destroy them explicitly. Another thing that some of you might be thinking of, what about SQL injection? Gosh, you're creating a SQL statement right there in the code and you're letting somebody pass values in. This is a function that is meant to be called by the program. So in this case, I'm going to allow it. I would not do this in a public-facing website where you're actually accepting values from the public or through a web page, but where in this case it's being called by something else within the code. The programmer would have control over what's being passed in. Inline SQL, as you see here, is not always appreciated by various developers. Some regard it as hard to maintain, but it depends on your preferences there. So that's something to think about too. But otherwise, this has been a very simple example of how to do some basic coding in VBA. And before I go, let me show you how this might be called from within Access. Here's a very simple form that I just created in Access. It has a combo box with 30, 60, 90, 120, and it has an amount field which uses the function that we just created in order to return the appropriate value. So if I change it to 60, it goes to 324, 120, let's try 150. And it changes it as we change the combo box. And let's take a look at the design on that. So it's really very simple. It's a text box, and it uses the function as the actual control source, and it references the value of the combo box. So if I use the build button here, you can see where it's actually set that function within the control source. And if we look at the functions that are available and click on the database itself, Access actually sees that custom function that I just built right here, and it can be used anywhere within the database. So that's a very useful aspect of understanding how to work with VBA. You can create your own functions, you can create your own subroutines, and work with data any way that you need to. You're not limited by the functions that Access has. You can create fully featured applications and do whatever you need to do once you get the experience. Thanks for watching. I hope you found this video helpful. You can find more information and articles on my website at comosoftware.com. Have a great day.